Dear students, now we shall study Kepler's law. So first, what are these Kepler's law? Johannes Kepler, he studied the planetary motion, that is motion of the planet. He observed the motion of the planet as well as he studied the data which was available, and based on this data and his observation he stated few laws which describe the planetary motion or motion of the planet. And that first, Kepler's first law is the orbit of a planet is an ellipse with the sun at one of the foci. So first we should know what is meant by orbit. Orbit means the path of the planet which revolve around the sun. So that path is elliptical form. You can see in this figure, this is ellipse. So planet always revolve around the sun in the elliptical orbit or elliptical path. And sun is, what is the position of the sun? Sun is at one foci, one focal point. So already we have studied ellipse has two focal point, one is here, one is second. Among that, position of the sun is here at one foci, one focal point. The second law, very important one, Kepler's second law, the line joining the planet and the sun sweeps equal area in equal interval of time. So you can see here in the figure the sun, I have shown with the letter S, and suppose here is a planet, it is at position A. So when it revolves around the sun from A to B or from C to D, so this distance covered from A to B and the distance covered from C to D, that distance is in equal interval of time. Okay, now what is the law states? The line joining the, see here, the line joining the planet and the sun means, for example, here you can see this is sun, this is planet, the line joining is AS. So this line AS, it sweeps equal area. So this area of the region SAB, this area which I have shown here by shaded portion. And suppose instead of A, suppose the planet is at position C, and in the same equal interval of time, if it moves from C to D, then this line CS sweeps area which is equal to this area. So that is area SAB and area SCB and area also SEF. So these areas are equal. This is the areas which are swept by the line, this line, in equal interval of time. So this is second law. The line joining the planet and the sun sweeps equal area in equal interval of time. And the third law, Kepler's third law is, you can see here, the square of its period of a revolution around the sun is directly proportional to the cube of the mean distance of the planet from the sun. Now here another one more term you should know, what is meant by period. Period of revolution. Now suppose planet starts from here point A or this place A, and after starting from, it takes a complete revolution, complete round, and it comes back again to this position. So the time taken by the planet to complete one revolution, that time is called as its period of revolution. Time taken to complete one revolution, that is called as its period of revolution. And mean distance, now you know that sun is at one of the foci, so the distance everywhere not same. So here is the distance less. If we compare here, this distance is more and this distance is most. So that average distance of we have to calculate. So what is that third law? So the square of the period of revolution is directly proportional, this is R, distance, directly proportional to the cube of the mean distance. Same statement can be written here as in the mathematical form, T square is equal to K R cube, where this K is called as constant. If this proportionality sign, if we want to remove, then we have to introduce here k as a constant. So same can be written here as, therefore t square upon r cube is equal to constant k. Thank you.